So, trig equations, our objective today. Thank you. Thank you.
Is this 5.5?
This is 5.5. 5.5. And what we're doing is we're solving trig equations. Okay? We're going to find all solutions, solve equations with multiple angles. It's all types of trig equations, okay? It's everything that you've been doing for the whole chapter. So it's just a bunch of different ones. And what's our objective always? To solve for x. We're always looking for the unknown, right? Where are you? So that's kind of what this is saying. In trig equations, it contains an x. That's what you're looking for. There's a value of x that satisfies the equation. So you guys want to jump into it? Let's do it. Here we go. So we want to... What was that? Disappoint. Well, just understand that none of the skills that you already know... sorry, that didn't sound to come up at all. All of the skills that you've already learned, you can apply, right? When we were doing Algebra 1, and we were trying to solve those equations with one variable, we always try to get the variable on one side, everything else on the other, correct? Make sense? So, I see, go ahead. I want to get all the x's together. It's on the right, I want to move it to the left. So I'm going to subtract 3 sine x to both sides. So that's 0. That would give me 2 sine x is equal to the square root of 3.
Basically just algebra, right?
Yeah, we're solving equations. We're using everything we've learned ever since pre-algebra now. But we're also throwing some trig on top of that.
So then we would divide by
Okay?
2.
So it's like, so we're having some cake, right? Algebra cake with some trig frosting.
Ooh, I like that. That sounds kind of good.
What? Oh my God, yeah, you've seen it all come together now, aren't you? I want sine x by itself. If we multiply by 2, what do? Divide both sides by 2. So that means that I've got sine of x, or theta, whatever you want to call it, is the square root of 3 over 2. Huh. Those two numbers look familiar. Which special triangle did they come from? The 30, 60, 90. So I can kind of grab my 30, 60, 90 here. And I know, let's see here, 30, 60, 90. Opposite 30 is 1. This should be 2. This is square root of 3, right? Which is opposite? Which has the radical 3 opposite to it?
60.
The 60 does, doesn't it?
Yeah.
So if I did the sine of 60, would that give me radical 3 over 2?
Yeah.
So what is x?
60 degrees.
X is 60 degrees. This is so difficult.
It is difficult.
Huh? That's not going to be your only answer, though.
Wait, is there any other solving it with that?
Whoa, commentate. Commentate.
Wait, I'm confused. Okay, so wait.
Hold on, your confusion.
Sine is opposite over the hypotenuse, right?
Correct.
How did the 3 get down here?
Because 60 is up here, and opposite to radical 60 is radical 3.
Okay, wait, I'm trying to build a triangle. Right. So if I'm from if I'm from an angle, the square root of 3 would be over there, and the hypotenuse would be 2, right?
Yeah. Here, did you draw it the other way? Let's draw like this. I thought I grabbed a different color. Let's do 60, 30 here. Okay. Here's 1, correct? Here's 2. Here's square root of 3. So opposite to 60 is radical 3. Hypotenuse is 2. Right? Okay. So we got 60 degrees. Everyone okay with that?
Yeah.
Now, why I said there's another answer is because the sign is positive, right? The triangle that I have drawn, technically this one, is in quadrant 1. Right? Where else is the sign positive? Right there. Thanks. That helps.
Isn't it
In quadrant 2. So, what is alpha at this point? 180 minus 60? Right? So, $1.20? So it's at both of those. So it's at 60 and $1.20. Now, that's in degrees. Math lab might not want degrees. It might want radians. So please understand that you might need to, what is it, pi thirds? Pi thirds, and this is
Isn't that
2 pi thirds?
yeah?
Yeah?
Yeah.
Doesn't. Yeah. Okay. So either one of those two would be absolutely right. Now,
Wait. No. Don't add more.
don't add more.
Stop there.
Never.
Using calculation.
I'm thinking. I don't know enough math to answer that. So I don't know when I would apply this for real. Whenever I think of trig, I'm thinking like sound and all that stuff. Do you guys know that scientists have actually taken sine waves and manipulated them, where they can pick up objects with just sound alone and move them? Video game stuff, right? Yeah. What they're doing is they're figuring out, or they have figured out, that they can take some kind of sine wave and then match it up with the other and trap objects between the waves and move them.
Like a decent sized object? Or like a...
Well, right now, I think, what do they do? I think they have like nuts and bolts. So they're kind of heavy. They started with like foam. You know, like, you guys have seen the dry foam stuff? So they've done that, but I've seen them where they do like nuts and bolts. So I think that's only going to get better. Which is pretty, yeah, right? I'm like, huh?
I'm gonna get a job doing that and then maybe a building.
Yes, you would be. But you'd have to have a really solid understanding of how they behave and how they work and what I can do and what I can't do. Yeah. Go on YouTube. There's videos of that stuff on there.
That'd be crazy if they like mastered it and could build up pick up buildings.
Oh, yeah, I want my house to be, well, they kind of do that, but they just pick the whole thing up. But that would be awesome, right? Like, just.
It's like
Okay. Oh, well, go back. I wasn't done. Go ahead.
Wait, are there more answers?
Well, remember when we got 60? I said, oh, look, we can also it can also happen at 120, right? And we goes, oh, yeah. Say that one more time. So every time I keep going around, it would happen again, right? What do we call those? All the other coterminals, right? So on pi thirds, it would also be pi thirds plus any what? 2n pi, right? Or 2 pi times the number of revolutions. Does that make sense?
Yeah.
I don't want to write n2 pi. That looks weird. n2 pi. So every 2 pi, correct?
Yeah.
So I can do 1 revolution. I can do 2 revolutions, 3 revolutions. Does that make sense? But that looks funny.
Yeah.
So I wrote 2n pi. But let's leave it like that. Does that make sense to you? But that would also be true for 2 pi thirds, correct?
Yeah.
And 2 pi.
So what would be the right answer?
Those.
That's what we would write.
Yes, because it happens at every single one of those points.
Okay. Oh wait, I wrote that as
I love math.
That's how you would put it into math. Right? No, you can't graph that. You would never stop. What does it mean? Okay, so here's what it means. Because it's always about what it means, right? Pi thirds is here, correct? And that produces the sign of radical 3 over 2, which is what we wanted. What this means, how do I get back to here if I go around the circle? I would have to travel a whole 2 pi, wouldn't I? So ignore this. So do you agree that pi thirds plus 2 pi would give me the next position? And then n just tells me how many times I've gone around. So I went around once, that n would be a 1. If I do it twice, then this would be 4 pi, wouldn't it? And if I did it 3 times, 3 revolutions, then this would be 6 pi. So all that n is telling me is how many revolutions I've made to get to the next one. There's 1, there's 2, there's 3, there's 4. And every iteration of n2 pi produces a positive radical 3 over 2. Same is true for the other guy where we had 2 pi thirds, correct? I would go around 2 pi once. I could do it again twice, 3 times, 4 times, however many times I want, which is what's being represented by n.
So those are like the coterminals.
Yes, exactly. Coterminals. Cool, cool? Good question. Anybody else? I'm over here. All right, you try.
Yeah.
You try. We're looking for tan 2x being equal to radical 3, and that's going to be in the interval of 0 to 2 pi.
Ours is always so much more difficult.
Yeah. What?
You know what? I've had that comment before. Like, you do one. No, here's the problem.
You're like, yeah.
If I told you, hey, you do this one, you would have thought it's hard anyway. But because I walked you through it, you understood what I was doing.
No, that one was so easy.
No, that one's easy. Just minus the other side. There's no tail on the other side. Why is it in there?
Well, does that tell you what type of what are you working with?
2x's.
Trigonometry, but yesterday we talked about double angles.
Oh yeah.
Oh.
Oh.
I hate it.
I don't like
I
it.
hate
It's
it.
not hard.
We did one like this yesterday.
I hate it.
Where we had to split it up into two.
Wait a minute.
To get the sign.
What's
Oh, I have
formulas?
those at home. I was gonna bring some in.
I was looking for this earlier. I forgot I wrote it out. Here it is. Analytic geometry. Oh, I missed some stuff. No. No. No, the 2 was in front. You're not doubling the tangent. You're doubling the angle.
So.
Huh?
You can buy minus.
Now, you don't have to really go into formulas if you stop and think about what's really going on here. What's going on? When it grows out, it does. But then I'd be fighting with it. What's your question? Okay. So what is sine? Sine is opposite over, right? So here's 3. What's opposite to radical 3? The 60. That's why. So opposite. Yeah, because they're saying what angle has a sine of radical 3 over 2? See that? So that's exactly what we're asking here. We're asking the tangent of twice some angle is the square root of 3.
So
Okay.
it's half of the square root of 3?
No.
It's twice some angle has a tangent of radical 3. So let's stop and think for a minute, okay?
Can we do tan divided by tan?
Let's stop and think for a minute, okay?
We're gonna stop.
I have some angle, I don't know what it is. Okay? Let's just kind of logic our way through this. I know that its tangent has a radical 3 there, doesn't it? Okay? And if that's a radical 3, then I'm almost I'm almost pretty sure this is a 30, 60, 90 type triangle.
Yeah.
That means that this is going to be a 60, which means this would be 1, this would be 2. That would work, wouldn't it? Because what is radical 3 as a fraction? It's radical 3 over 1, correct? Which is the opposite over the adjacent, which means it's that. Correct?
Yeah. But what? But what?
But what? Okay, so I know that the angle is twice the angle, correct? So the twice the angle equals how much? 60.
So it's 30.
So x is 30. Oh!
Wow, mind blown.
It's so much.
That's what I was looking for on formulas. It's so much harder with formulas.
It is, because like I'm trying to look for a formula for it, and there's like what? So x is equal to 3.
What he's saying is, basically, I just like forgot about this.
That probably is going to make way more sense than any formula. Let's see here.
Yeah, because I was like, you can't do tan 2 of theta because, well, I mean, you could, but.
I'm trying to find it.
I mean, wouldn't that just do much more work?
It is. It's a lot more work. Here it is, double angles.
Yeah, because if
So I would have
2 tan of.
I would have tan 2x is equal to the 2 tan x over
1 minus tan squared of x.
1 minus tan square of x.
And that just does a bunch more work.
So that means that this would be 2 tan 2 times, right?
Is it asking for degrees or is it asking for like radians?
Radians.
It's so here's what, like I said, for me it's easier to think in degrees and then just go back and convert that into radians. Okay. Dang.
I don't know if you could really do it that way. Because technically your tan 2 of x would be.
So that means that all of that would simply be equal to.
I don't know if you could really use the formula there. I mean, you could. It's just so much more work. And a lot harder.
Right.
A lot more difficult. And then I don't think there's much else that you could do.
Yeah, I don't know.
I think sticking with
I
the
think
triangle.
if anybody's interested in the formula way, I'll try to find a way. But what I just did made the most sense to me. Did it make sense to you?
Yeah.
It did, didn't it?
I think I'm kidding.
I'm gonna make a note.
Can I just have your book?
Can I just have your brain?
I didn't even use it.
Can I have that?
We were talking about that in staff today. Like, would it be nice if like school was just like, come, let me give you my knowledge.
Yeah,
Like,
that'd be so amazing.
I see now. That makes sense, totally. All right, try it again. Try it again. Here's your next one, guys. Oh, sorry. Of course, you guys understand that that happens a couple different times, right? And then you're gonna do the repetition again. Just throwing that in, that caveat in. Here's your next one. Try, see what you can do with this round.
Oh wait, okay. Can you go back real quick and tell me the rules?
The rule?
Yeah, like for the other one we did it was pi thirds plus n pi base. Is that one?
Say that one more time. What did I do?
Wait,
It sounds kind of cool what I did. Now that I hear it out your voice coming. Shh. For the first one that we did.
we came up with pi thirds plus n pi and 2 pi thirds.
Oh, okay. So you're talking about the rest of the formula. So we found out that it was. We said that x was 30 degrees,
Yeah.
which is pi sixths,
Yes.
right?
Is it also 2 pi?
Now this one is not going to be. You don't.
It wouldn't be 2 pi.
Yeah, I was going to say. I don't think you do 2 pi
It wouldn't be 2
for
pi.
this one, right? You would be doing. What is it? Pi?
Yeah, it's pi.
A
because-
pi on this one?
Yeah.
Because if remember the domain repeats itself every pi radians
Yeah.
for this one. Sine and cosine has a 2 pi thing going on. Tan only has
Pi.
pi.
Oh, I gotcha.
So
It's plus pi.
Yeah, instead of 2 pi, it'll be 1 pi.
yeah, so it'll be
And
n
then
pi halves.
there's a second,
Wait, what?
is it in the other column?
Yeah, because then it would do it. It wouldn't
Oh
be
yeah, it would be n pi halves. It would be
Wait, n pi half.
yeah, because this is 2x, right?
Yeah.
So 2x equals 30.
Oh, okay.
So when you get pi 2x equals plus n. Thank you. Let's see here. No. 2x equaled 60 degrees. We said x equaled 30, didn't we?
Yeah.
So 2x equals 60. That repeats itself every n pi. Let's divide everything by 2. So you're going to get 30 plus n pi over 2. Convert that into radians. Okay? Because x was 30. We were right. But 2x
Okay.
equals 60. You still have to go back and half everything. Thank you for asking because we would have missed that altogether. That's a great.
Well, I wouldn't have passed, so where's the answer?
Um,
And then is there another?
you're okay with this?
I'm okay with that.
Okay, so then this is just pi 6 plus n pi over 2. And then what would happen again?
60 degrees.
It would happen in the negative side?
Yeah.
It would happen down here in quadrant 3, right?
Yeah. And then
Which would be
210.
7 pi sixths,
Yeah.
right? Plus n pi halves. Yeah, because this is going to be 6 of them. Plus one more would give you,
It's gonna make us final.
would make you 7 pi sixths. Okay?
Okay, yeah, I see it.
Yeah. 180 plus 30, 210?
Yeah.
Yeah, 210.
Yeah. All right. Do it, do it, do it.
Right, can we do a problem now?
Here we go. Back to here. Could we do like a Pythagorean here?
No, wait, well, I mean, you'd have to get cosine squared of x by yourself, wouldn't it? Wouldn't you have to get cosine squared of x by itself?
Yeah.
So you would just add 3 and then divide by 4 to get cosine squared of x equals 3.
Oh no, not 3, 4, 5.
It's 3, 4. No, it's just
Yeah, because that's opposite. That's adjacent over hypotenuse. Hypotenuse is 4.
Yeah,
It's 3, 4, 5. It would have to be. It would have to be. Yeah. If I would have to be the hypotenuse for it to be the 3, 4, 5.
Or it's adjacent over hypotenuse.
Guys, I don't know if this lecture is even recording because
You stop.
we stopped it and then we started again. It looks like it's good. It looks like it's good. I'm looking at the tube of view, and it's on there. So
The tube of you.
the
Hold on,
tube
let
of
me come on
view.
then.
The YouTube.
Hold on, but check.
I'm gonna check it out.
And then what's
So after you do that, wouldn't you do the triangle and then 4, 3, and then you do 1 minus the sine of that?
So if you did the triangle here, cosine is positive here and here.
Yeah.
So this is what, 3 here, 4, 4.
Yeah.
Oh,
You
yeah,
probably have to
good.
do some
We just keep going.
Pythagoras theorem.
Yeah. Well, Pythagoras
Oh
theorem-
yeah, the power. Did we do power reducing?
No, we didn't go over it though.
We wrote power. Oh yeah, you could have used it there. Maybe we don't want to do this problem because we didn't do power reducing.
I mean, we had the pictures and stuff from it.
But simple question: how do you get rid of a square?
You would just square root it.
Square root it, right? So I square root here. That's going to give me cosine x is equal to plus minus the square root of
3 over 4.
3 over 4. Let me see what my notes are saying here. So you have that, yeah, and then it just repeats itself. So that's, oh, what's the square root of 4?
2, so it would be the square root of 2. Yeah, there you go.
So we're back to a what type of triangle? 30, 60, 90.
How do you comment on a video?
How do you get rid of a square?
Oh,
Oh.
the square root. Okay.
Yeah.
How do we go from where to where? Oh, add 3, right?
not that. I mean,
Not that.
what did you do?
I know what. Wait, right?
Somebody commented on your video.
No, we built the wrong triangle because that would have been, this one would have been for cosine square. And we don't really want to work with cosine square, right? Because we don't, do you know stuff for cosine squares? I don't. No. And I've never learned it. So, we only deal with sine, cosine, tangent, secant, cosecant, cotangent. Usually squares, we want to minimize them. Okay?
So then after that, what angle would that be? Well, that could be 2 angles. It'd be,
Opposite to 30, that's a 60, isn't it?
yeah.
So, pi thirds? Pi thirds?
Yep.
No, it says pi sixths.
Pi 6. Oh yeah, that's 30. Pi 6 is 30.
Oh, yeah, there you go.
So it would be pi 6.
Oh, yeah, because sine would be, yeah, you're right.
Yeah. So then what would the rest of it be? The actual answer?
Still be a lot of answers, though, isn't it?
Yeah, because you have like,
Because you got the positive and the negative versions, which means
so
you
you
got
have 4.
Yeah, you got 4 sets that repeat. Wow.
So you would, because you have pi 6 thirds, and then
You guys done writing?
Yes.
Ask me.
So I got 30.
Ask us, because we all love the discussions.
I got 30 degrees, right?
Oh,
And then
well then, And then it would be every
2 pi.
repetition of that, 2 pi, right?
Yeah.
But the problem here is that, like we were talking about,
You don't have-
because this is plus minus, because this is plus minus,
It means it's your
you have a
positive
positive cosine here, but then you have negative cosines here. So it's really happening quite frequently. You're doing it here, and then another 180 that puts you there, and then you're going from here to here, and then another one again there. So it's really just happening. It'd be this one, and then so it would be what, pi?
Maybe pi.
What do you say, pi thirds?
Yeah, pi thirds.
Pi thirds plus every n pi,
Yeah.
right? Because
Yeah.
from here to get to here is just 180.
Yeah, it's just 180.
Is it or is it not? If this is 30, let's.
Yeah. Yeah, it would be, wouldn't it?
I don't know.
Because if you're at 30 and then we're going, what's that, 210, right?
So this is 30.
Yeah.
This will put us at 210.
Yeah, and then you just 210
And
minus
then
30
you'd
is
be
180.
here, and then yeah, so
Yeah, it's just
it would be
180.
this, and then the other one would be
Pi,
3, 4, 5 pi,
yeah, pi.
5 pi 6 plus every n pi. So it's happening a lot. A lot. That should be the, yeah.
I actually get it.
Okay.
We're stupid too.
He sounds like
Like
a
a
dolphin.
dolphin.
No, he sounds like the fish on the SpongeBob.
Is that a dolphin?
Yeah,
No, that's a seal.
that's a seal. Dolphins are too.
All right. Let's try this one, my main man. Let's solve this equation right here. This one's actually really, really simple. This is a 45. Sorry, a pi fourth.
Okay, so funny story. Can you split this in half?
Yeah, solve it for x.
You can divide by sine.
That's the
of
entire
x.
question.
You can of x equal 1.
You see it already? You
Yeah.
can just look at it now like I know it already.
Yeah.
It's just pi fourth plus what? N pi?
Yeah.
What? Don't nod your head at me. She'll understand.
I don't understand either.
What?
Does it make
Divide by sine and you
No,
get
I
sine
got
by
10 what?
Notice that both sides have sine, right?
Oh, yeah.
So I can divide both sides by sine x. 1, 1. That means that tan of x is equal to 1. There's only one triangle whose two sides are the same. That's the 45, 45, 90.
Is there any way to do this algebraically without doing using triangles?
No.
This is not algebra. This is
Hey,
I
trigonometry.
don't like trigonometry.
I love it.
There probably is, but there's going to be so much harder.
I like this. I actually understand it.
I agree. I agree.
So it's 1, 1, 2, and then after that, what'd you say it would be equal to?
Well, then that just is going to be, that means this is 45. So the tan at 1 is 45 degrees. It might also be shoot, what's 180 plus 45?
180 plus
225
Yeah.
degrees plus every, what is it? No, every pi n, right?
Yeah.
Every n pi.
Yeah, every empire.
So we don't even need this one
Yeah.
because that would put us there anyway.
Yeah.
So this would be
Because you're doing
pi
it like
fourth
already to the
plus
next one.
n pi.
You're only moving 180 degrees in order to get to the
Why are
225.
we moving?
Because it's after like every revolution.
Because even if you go to this triangle right here, is what we're saying. This is -1, this is -1. Negative over negative makes a positive
Positive
again.
and it's still 1. So you don't even have to worry about the
So I could just
25.
multiply pi over 180?
That's not always going to happen though, but yes.
Yeah,
For this
okay.
one, yes.
Thank you.
Okay?
I'm probably like I do really good in class and at home, but then like when it comes time to the test, I'm just like,
Ah.
It's like I'm overwhelmed with everything that we did.
Her sister. Her sister. Her sister's so cute.
Next.
Little eyebrows.
Sorry. Over here.
Wait, why is that one only n?
It's just like
Why is it
Because if you notice, tan's right here. Well, think about for starters the domain of tan. It repeats itself every pi, correct?
yeah.
So we would get positive and negative here. We'd only have to travel 180 to get to the next part. Travel another 180 to get to the next one. Travel another 180 to get to the next one.
But even on the negative one,
So I don't have to do 2 pi. I can just go over pi.
Pi sounds really good. I throw it.
I understand how to do it. I just choose not to. Okay, try.
Put a 0.
It's
Um,
it's 0.
it's 0.
Actually, wait a minute.
Guy was like, jokes on fair. That's
He's like, wait. He's like, wait a second.
Maybe it is a
Maybe it is.
Would you subtract sine x to get? No.
I see something. I see
Can't do that.
So if you subtract sine and then you divide cosine on both sides, if you can you do that? Can you divide cosine to both sides, right?
Yeah, because then you get rid of
And
one.
then
No,
you
well,
would have sine over cosine, and like.
no, because it's not.
No, because they're on the same side.
Yeah.
So no, but then if you subtract sine.
Sine. Same if you subtract sine to the other side.
Here, wait.
What is this now? I looked away for 2 seconds.
Sonny, you're crazy, girl.
What did she say?
She said, "What is this now?" I only looked away for like 2 seconds.
So
You ever seen that Key and Peele where like the guy talks to Obama?
Like Obama.
Oh yeah, the cat.
Talks, yeah.
Yeah.
Like he's his anger translator.
Oh, I think
She's fine. Because I don't say it, but she says it.
Well, so cosine 2
That's funny.
of theta is equal to cosine squared of theta minus sine squared of theta. So what do we have to do?
No,
that?
because
I'm gonna do it.
that does not work because it's the angle that's being doubled.
So
wait, so would you have to have
So all you're doing is dividing twice an angle by the original angle.
cosine squared. Wait, Mr. Munoz. So cosine 2 of x is equal to cosine.
This is telling me that the angle's been doubled. Yeah, go for it.
So cosine 2 of x would equal cosine squared of x minus
Cosine-
sine squared of, because it's
It would equal what?
it'd be cosine squared of x minus sine squared of x plus sine of x. So then you'd get cosine squared of x minus 1 sine of x.
Is that
because
is
you're
this
gonna-
is this the double angle?
Yeah, that's the double angle. Of
All of
cosine
this
to
is the
x.
double angle?
No, just this.
Oh, just this too?
Just this right here is the double angle.
Okay.
So then after that you would get rid of one of the sines x, so it'd become cosine squared of no.
No. No. No. So let me tell you why this does not work. You use the double angle. Double angle is cosine square x minus sine square x.
Yeah.
Okay. And you thought that you can eliminate one of these, right?
Yeah.
Think about this real quick. If you have x squared and you take away x,
And then it would become sine cubed.
no, not even that.
Really?
Can you even combine these two?
No, because
They're not like terms.
What
They're
if
not.
you move the sign over and then do the square
But
root?
cosine squared of x minus sine squared of x is equal to
No, that's plus.
oh plus okay.
It's plus.
Evil too, look at
Is
Yes.
there a thing of the square root of sine? Can you do that? Can you make the whole angle like a square root?
But I know that cosine is 1 minus
sine squared.
sine square x minus sine. You know what? Let's not go with this one. Let's go with the other one.
Which one?
Let's go. Let's try this. Let's try cosine square x minus 1 minus cos. Oh, that's going to give me a positive again. I don't want that.
Yeah.
Because
Oh yeah.
I was thinking the negative could cancel out with the negative, but
Yeah,
but negative negative would make positive again. Um,
Well, cosine squared of x is like, or cosine 2 of x is. You have other formulas, or you have other ones.
I need to bookmark my page here. I can't find it.
What if
think
you
it was
did what if you did the 1 minus 2 sine of? Oh, I didn't think of that one.
Oh, here it is.
The 1 minus 2 sine of x, 2 sine squared of x. But then you
That's
still
some
can't do that.
difference. Here's my double angle.
You still can't do that.
Imagine us.
No, well, I'm trying to do it with you guys. Like
You
I
know how
have,
to do it.
we've done it already. So
Which one would you use? You have three. You have three.
we have a couple of options, right? So.
Because you can't really use the 1 minus 2 sine squared of theta or x because you're still gonna. Can you? I don't think you can because they're not like terms.
How about we just meet at your
the sine.
Yeah, I want to. I don't think my brother was.
You can't add the sine to the sine or subtract it because well, no, then it's negative.
Equals 2 cosine minus 1. That's a sine. Well, because what I was thinking was, if we have, because I wasn't even thinking formulas. I can't formulate this. But here's what you understand. If you think about this real quick, that we know that the sine of one angle, let's go 30, 60, right?
Yeah.
The sine of some angle, like let's do, what is this, 1, radical 3, 2? So the sine of 30 is 1 over 2, correct?
Yeah.
That means that the cosine of 60 is also 1/2. Do you see that?
Yeah.
So my thought is 30 is a double angle on 60, isn't it?
Yeah.
And if I can find a position where one of them is negative but the other one is opposite, then I can find that angle. Okay? So, because then I would just go this minus that. And that's the idea right here. What happened?
There's not an easier way to do this.
You have to think about it. So, do you understand what I said right here?
So this whole chapter is like logical thinking, not like rules. It's like
Yeah.
you got figured out.
You have some rules, but it's going to be a lot of...
It's like your thing. Yeah, that's,
Mhm.
I think that's my problem.
Yeah, you're pushed to think. So do you understand my reasoning here? I know that the sine of one angle is the same as the cosine of the other. And if I do a 30, 60, 90, I know that 30 is, 60.
Is twice.
Now I could double 30 to get 60. Hence my double angle there. Okay? So I'm going to go, now all I have to think about is where is one of them positive while the other one's negative. Well, cosine is positive here and negative in this quadrant. Sine is positive and negative in this quadrant. Okay?
So it's either in quadrant 2 or 4.
Because that way, when I combine them, one's opposite, one's positive, they would combine to 0. Does that make sense?
Yeah.
So there it is. That means that this would be, what, 30?
Yeah.
Because then I would just double 30 to get my 60.
Well, wouldn't that be negative 30 since it's going?
Well, okay, so yeah, it would be negative, but we don't want to do negative 30. So we're going to want to go 30 here. That means that we actually have 150 degrees where it happens, and then we also have, where else does it happen? 150, 360, 330.
Yeah.
But it would repeat, right? Because isn't that complementary? Isn't that 180 between them?
Yeah.
Is it 180 between them?
Because
30 plus 180 gives me 330?
30. What 30 plus 180? That'll get you.
I was trying to think of
150 plus 180, does that give me 330?
Yeah.
Does it?
Yeah.
Someone add that, 150 plus 180. Yeah, that's 330.
That's 330.
Yeah, so then that means that would be at 150, and then every
Every
pi and pi.
and pi.
Yep. So,
Yeah. And then 2.
2
So what we're trying to get in the end is the rule.
is what the angle it is. Yeah, this, well, more importantly, where does the angle happen? And then how often does it repeat itself? So, if I create this triangle, take a look. What is the sine of 30? 1 over 2, right? So that's 1 over 2, positive in this case. And then what's the cosine of twice 30? Well, that's 60, right? Well, cosine, oh crap. No, we're still going from the same angle, right?
Yeah.
So the
Yeah.
cosine of this guy is negative.
But then that doesn't.
Oh crap, that didn't work, did it?
No, because then that would be.
I gotta stop saying that word. So do I want it to be? I gotta get one to be positive. I gotta be the other one to be negative.
Wouldn't the sign have to be negative?
Okay. All right. I'm gonna look at my notes now. Because I'm going crazy here.
I
If
do
you're
that
going
every
crazy,
day.
we're all going crazy.
Oh!
He's like, so much easier when I look back at my notes. What was it?
They did do the cosine, and then they factored it.
They factored. Did they factor out a sign?
So, no.
No.
Well, cosine 2x is a double angle.
Yeah.
There's one formula on the double angle on that, which is 1 minus
This sign.
2 sine
Yeah.
square x plus
Sine X.
sine x.
So they
So
do.
if we rearrange those, that can actually be factored.
Yeah.
So I would have, what is it, negative 2 sine square x plus
Sine.
sine x plus 1.
And
And then that gets factored into
uh-huh.
2 pieces.
You're kidding me.
No, I kid you not.
I don't like to not
2 sine x plus 1 and sine x minus 1.
Seriously?
Because what they did, so that 2 is not negative, is they multiplied everything to make it positives.
Okay.
So you got 2 sine square x minus sine x minus 1, because that's legit, right?
Yeah.
So that means if I want to get 2 sine x, I'm going to have 2 sine and then sine. And the only way to get 1 is 1, 1. Yeah, thank you. Woo! Got me a little snacky poop. Okay? And I didn't see that. So that's negative. That means one's going to have to be positive, one's going to have to be negative. The bigger of the two is going to be negative, so it's going to be this guy negative, this one positive.
Okay.
And then I can find where these guys equal 0. So I can take my 0 product rule. That means that 2 sine plus 1 is equal to 0. Sine minus 1 is equal to 0. So I'm looking for where the sine is 1. And then I'm looking for where the sine is negative 1/2. That was way better. Yeah, it is way back, huh? But it all comes back together in a big loop again. I should have looked at my notes sooner. Yeah. Where's the sine 1?
Wait,
No, that's a tangent.
That's it. Yeah.
That means it's going to be 90.
Yeah.
Sine goes up, right? If it's 1, that means
See,
you're 90.
see, I thought of this earlier, but I didn't know if it was right. Like, I thought of something similar to
Yeah,
it.
because negative 1 would be at 270. So you got a 90, which is pi halves,
And then
and
you
then sine,
said-
and then sine negative 1/2, that's just 30.
Yeah.
Negative 30. Okay.
I thought of using that rule earlier, but I
Say that
didn't know
one
if it was going to work.
Well, it goes in radians and then the repetitions. So we already figured that this is 90, right? Which
Yeah.
is pi halves.
Yeah.
And then this one would definitely have to be every circular motion. Because it's
it'd
only
be
positive
pi.
up top, right?
Yeah, so it'd be
So this
pi.
would be 2 n pi. And this one, negative 30, it's negative 30 degrees, which is technically 330 degrees. Positive, which is, shoot, 11?
Okay, I'll love it.
11 pi 12ths? Yeah?
Yes.
Plus 2 n pi. Okay. I want to show you something that I think would have probably helped a little bit. No. For here, because you have to do some of these where like tan x is equal to 3.044. You will need your calculator for this. So if you don't have one, then you might want to just take some notes, or if you can run up there while I load up mine.
We have 3 minutes.
That's all I need. Okay?
Wait,
Because
can you
we're
go back to the other side? I'm sorry.
yeah, no problem.
Thank you.
So
We have 1 minute.
so our objective for this problem is to find the angle where the tangent is 3.044. And all we really need to do is use the tan inverse, right? I know the ratio. I want the angle. I know the ratio. I want the angle. So I'm actually going to just punch this into my calculator. Make sure that I'm in radian mode. I am not. So mode, radian,
So then you would go.
second quit. Then I just go second, tan inverse. What was it? 3.1044.
0.044. Yeah.
And then just push enter. And there you
Your
are.
answer? That's your answer.
1.25. Is that what I had?
Yeah.
Yeah, there it is.
Okay.
And because it's tangent, it happens at every pi
I
radian.
am roll.
So here's our plus pi.
Oh, okay. Okay.
Okay?
Alright.
Calculator part's super easy.